Okay, we have a disk, and this disk has some thickness. You could call it just T, or you could call it dx, because x is running out in this direction. And if you started, you could then start to go and you do it for volumes, but we're only going to do 2D, only planar. Okay? So, but you can see why somebody may prefer to talk about the thickness of the disk as dx. All right, what is the radius of the disk? R. And it's homogeneous, it's constant, density is constant. So to determine the mass moment of inertia of that circular disk of thickness dx, how do we do that? Well, I would look at it like this. I would put the disk this way and look head on to it. And this is the center, G, of that disk, all right? And we're going to talk about going out a location R. And if we go out a location R and then go a dr, what does that give us? That gives us a little circular ring, where that circular ring is constant distance away from the point of interest. Okay. What is the mass of this little chunk of ring? So little dm is equal to my density times my volume. My volume is going to be my circumference, 2 pi r, times the thickness, dr. That's the thickness looking at it. And then the other thickness is either t or dx. Either way, let's put dx. Fine. Do you see that this, where do we get the 2 pi r? That's the length going all the way around. You multiply that by the dr, that gives me an area. Multiply by the thickness, that gives me the volume. So that's our little chunk of mass. And so to calculate I about the point G, this is G. Let me get rid of G right there. That's equal to the integral of r squared dm. That's equal to the integral of r squared. Dm is replaced by rho 2 pi r dr dx. The dx is constant. It's not a function of r. The 2 and the pi and the rho, they're all constant. They can come outside. So I get 2 pi rho dx, the integral of r. We have r squared times r, that's r cubed. dr, we go from the inner, 0, to the outer, cap r. Isn't that cap r, the maximum? So at this point, can you do that integral? Sure, it's 1/4 r to the 4, evaluated 0 at a cap r. So that's equal to 2 pi rho dx, 1/4 cap r to the 4. And then we just remember that the total volume of our disk, just leave it as cap, V, is going to be the pi r squared times dx, isn't it? And so what I'll do is I'll put the pi and then take 2 of the r, take that r squared out of there, and then the dx. And then if I multiply that by rho, that gives me my mass of the disk, rho times v. And so what we're left with is we have 2 force. We have the mass r squared. 2 force is 1/2 m r squared.